Hello and a warm welcome to everyone joining us today. I hope you're having a fantastic day so far. Today we are going to talk about the triad of network efficiency and how you can build the foundation for seamless networking by crafting a cohesive network strategy unifying DNS, DHCP and IPAM. Before we move into the presentation, I'd like you to confirm in the webinar chat panel if you could hear me and see the presentation. Very quick introduction. I'm your host, Akshara GJ, product expert from Manage Engine. I collaborate closely with the marketing teams for Manage Engine DDI Central and Cloud DNS. A big part of what I do is talk about the critical network infrastructure services like DNS, DHCP, and IPAM. I'm here to share insights and knowledge that will help you harness the full potential of these critical network services. For the agenda today, I'm going to walk you through the critical role of the DNS and DHCP services in your daily network operations. Next, we'll go through the challenges to be tackled while managing core network services in silos. Moving on, we'll explore solving these challenges by integrating the core network services. We'll then look at how you can unlock network intelligence by conducting a comprehensive analysis of essential network data like IP lease history and query traffic. After that, we'll discuss automating IP allocations, customizing device configurations, and optimizing Pixie booting on a large scale. Finally, we'll wrap up with how Manage Engine can assist you in this journey. To start with, I'll be explaining in detail the role of specifically the DNS and DHCP services in your daily network operations and why are they so important. Here's a corporate network. So this is how a typical corporate network is organized. The image here illustrates how different various components are interconnected to provide core network services and internet connectivity. So you can see multiple VLANs configured here, a separate VLAN for office end users, a different one for handheld devices, and a special one for your core network services. Many organizations also deploy a guest network to enable free Wi-Fi for their visitors. To join one of these VLANs, you'll need an approved identity, like a host name and password. These host names are human-friendly means of identifying users or services just to simplify network administration. But behind each name lies a machine-readable IPv4 or IPv6 address identifying each user and service hosted in a VLAN. So what do the core network services, DNS, DHCP, and IPAM, do to help hosts join a designated network? The IPAM basically acts as the authoritative repository that audits and tracks the IP address inventory. So who helps in the translation of a host name into a specific IP address? It is the DNS, domain name system. Let's explore the role of DNS in a LAN. DNS basically acts as the yellow pages or the phone book for all the hosts or services in a network over which it is deployed. As you can see in the image, whenever a user tries to access a particular website hosted on internal servers through their browser, the browser immediately takes the request to the local DNS servers. The internal DNS servers act as the internal resolver and try to find the authoritative DNS server for that particular website. If these DNS servers have the authoritative record for that requested website, they provide the IP address for the internal server where the website is hosted to the client. This enables the client to establish a secure connection with the internal server hosting the requested website. So what happens when your local DNS servers do not have the authoritative answers for the website you're requesting for? This brings us to explore more on the role of DNS in WAN. So when your local DNS servers see that they do not have authoritative answers for the website you're looking for, they immediately take the request to the public DNS resolver. The resolver checks whether it has cached the IP address entry previously for that particular website. If there is no trace of any cached response, the public resolver takes the responsibility of finding the authoritative name server for that particular website on the internet. For this, it breaks down the search by first approaching the root server represented by the dot in the website name. And then it approaches the name server for the top level domain name, which is the .com portion of the website. And finally, it finds the authoritative name server for manageengine.com as shown in the example here, and returns with the IP address of the web server hosting clouddns.manageengine.com. This makes it easy for the client to establish a secure connection with the web server identified with that particular IP address over the internet. But even with these systems, DNS and IPAM in place, the situation is far from resolved. We are in need of a special service that could provision IP addresses to all the participants in a network called Dynamic Host Configuration Protocol, also known as DHCP. So how does a DHCP server help a user connect to a network? The image here shows the interactions between a single DHCP client and the DHCP server. First, the DHCP client requiring IP address sends a broadcast message requesting an IP address. The DHCP server instantly recognizes this and offers a range of IP addresses to the DHCP client. The DHCP client, on the other hand, selects a particular IP address from the range and pass the particular IP address to the DHCP server. The DHCP server acknowledges this selection and helps the DHCP client to retain that particular IP address. Now, this is just a dialogue between the DHCP client, a single DHCP client, and a DHCP server. So how does the DHCP server handle such multiple DHCP clients in a local area network? Let's explore the role of DHCP in a LAN. Consider a network where each user or service has a fixed IP address. With the advent of 5G and bring your own devices trend, the number of devices each employee brings to work has increased significantly. Coupled with the explosion of IoT, Internet of Things, there's immense pressure on the availability of IP addresses, leading to a potential scarcity. This is where DHCP steps in. DHCP dynamically leases out IP addresses to users for a specific period, say 24 hours, when they log into a network. If they log out and don't rejoin the network within 24 hours, the DHCP server recycles the IP address, reallocating it to another user in need. DNS, DHCP, and IPAM are indeed the silent workhorses of the internet, directing traffic and connecting users to the private and public networks seamlessly. Yes, DNS, DHCP, and IPAM work well separately. However, you gather more data and know valuable insights. This is best illustrated by the image over here, showing the daily reality of many network administrators. Here's a network administrator managing DNS, DHCP, and IPAM from different consoles. To make a single host join a network, the admin has to move from one console to another, checking current configurations, verifying the availability of IP addresses in the IPAM, creating hostname records for the user in the DNS server, updating leases in the DHCP server, and ensuring coherence across the three services. It's a juggling act requiring high precision and, quite frankly, a lot of time. This fragmented approach can lead to inefficiencies, errors, and a heavier workload for the network admin. So, what are the challenges of managing DNS, DHCP, and IPAM in silos? The challenges of managing these three services in silos are manifold. Firstly, When these core services are managed in silos, a network admin faces a significant decrease in visibility. Without a unified view, it's challenging to track and manage all the resources effectively, leading to blind spots in your network infrastructure. Lack of complete control is another major concern. Siloed management means settings and policies are not consistently applied across the network, making it difficult to enforce global standards and compliance. This also gets time consuming as each service requires separate maintenance, troubleshooting, and policy enforcement, which leads to an increase in administrative overhead and a decrease in efficiency. Manual management of these services increases the likelihood of mistakes. Misconfigurations can lead to significant issues, including downtime, which can be costly for any organization. IP conflicts are quite common when DHCP is not properly coordinated with IPAM. Without synchronized management, two hosts could end up with the same IP address, leading to network conflicts and connectivity issues. Lastly, data triangulation stems from the difficulty in correlating data across DNS, DHCP, and IPAM to make informed decisions. When managed in silos, it becomes a tedious process to align the data points and derive actionable insights. So let's focus on a couple of typical problems encountered in an office network that manages these core services in silos. A scenario illustrating an IP conflict between two users within an organization attempting to access the same network. A user named John is automatically assigned an IP address by the DHCP server in line with the standard procedure actually. Concurrently, another user, Bob, had been inadvertently assigned the same IP address by a network technician. Now, both John and Bob are attempting to connect to the LAN but face connectivity issues. Each user submits a support ticket to the network administrator reporting their connection problems. The administrator, working to resolve the issue, searches through DNS and DHCP logs across different consoles to identify the source of the IP conflict. This process is so time consuming that it takes hours for the network admin to pinpoint such discrepancies and enforce proper IP address allocation. This brings us to another problem, which is easy access to malicious sites in a typical office network. Let's consider a scenario where a user from your organization, after using a public free Wi-Fi at a cafe or airport, unknowingly gets his or her system infected by a malware. Upon connecting to your office network, the malware covertly accesses malicious sites and spreads laterally, infecting other hosts and services. Meanwhile, the network administrator notices devices and services failing but cannot immediately pinpoint the cause or identify the gateway through which the malware is operating. The admin spends several hours examining the DNS and DHCP logs to determine the source of the traffic and to quarantine the infected device. In this instance, the isolated management of core network services increases the mean time to resolution. This raises the question, isn't there a more unified way to manage these critical services? The answer is yes. By integrating DNS, DHCP, and IPAM services into a single cohesive system, you can easily resolve these challenges and streamline your network operations. There's one tool that embodies this integration and can solve every critical network challenge. This tool is called DDI. So what's DDI? It's a unified solution that tightly integrates the three core network services, DNS, DHCP, and IPAM. So why are organizations demanding a unified solution for managing the core network services? For this, we have some compelling insights to share from a recent study by Enterprise Management Associates or EMA. On your screen, you will see a breakdown of key drivers behind why organizations are increasingly investing their time and resources into the DDI technology. Topping the list is cloud migration. Close behind, respondents indicated that network and IT automation initiatives are propelling them towards DDI investments. Security is another critical driving factor. Risk assessment and compliance, which are crucial for risk reduction, also stands out as the third significant factor, along with application modernization and the shift to cloud native applications. The Internet of Things and Industry 4.0 are also influencing organizations to adopt DDI. Service outages and performance issues caused by DDI errors, along with mergers and acquisitions, also motivate organizations to look into DDI. As we continue our exploration, let's look at the benefits of DDI solutions in network automation. Let's turn to some recent findings from the International Data Corporation, or IDC. The chart you see here illustrates the key advantages organizations have realized by accelerating network automation with DDI solutions. These statistics are based on a feedback from 278 respondents out of 1,100 respondents in various sectors, providing us with valuable industry insights. Top benefit leading the chart is risk reduction. The respondents found that the DDI solutions provided consolidated and trusted network data along with management simplification and agility. We see that the organizations experienced improvements in service continuity along with process standardization. Lastly, but importantly, organizations were able to gain significant financial benefits using a DDI solution. Let's now focus on the compelling data provided by IDC, which underscores the impact of DDI solutions on organizational performance. The graph before you presents a stark comparison between organizations using DDI solutions and those who are not. Out of 1,100 respondents, 278 respondents have shared insights that highlight the difference DDI makes in terms of value creation, cost control, and operational efficiency improvement. In the context of value creation, the respondents using DDI experienced improvements in terms of process standardization, faster service deployment, and IT team productivity and agility improvement. In the context of cost control, the respondents using DDI solution experienced improvement in terms of network capacity planning and operating cost reductions. In terms of operational efficiency, the respondents using DDI solutions reported improvements in reduced network outages, security and compliance improvement, and improvement in overall operational efficiency, and improvement in mean time to resolution, MTTR improvement. So how can a DDI solution benefit your organization? A DDI solution can benefit your organization by offering a centralized and contextualized visibility. It enables you to take complete control over your core services from a single window. It reduces the network administration time and costs, scales your network for optimal performance, helps you automate and streamline the lifecycle management of IP resources, simplifies network troubleshooting. It helps you effectively analyze the usage of your IP resources and enhances the security posture of your network. And that being said, how can Manage Engine assist you in adopting a DDI solution? Manage Engine has launched a new solution called Manage Engine DDI Central. It is a user-friendly, specialized solution that unifies DNS, DHCP, and IPAM into a single platform for improving operational efficiency and network stability. It manages your existing ISC Bind9 and ISC DHCP installations and can also set up new clusters. What are the core functionalities that make Manage Engine DDI Central an indispensable tool for network administrators? Firstly, it automates the discovery process, ensuring that all your DNS, DHCP, and IP address configurations are captured, cataloged, and consolidated into the DDI Central console for easy management. By doing this, it enables you to take complete control over your internal and external DNS, DHCP clusters without the need for any other tools in between. You can holistically view and directly manage all your DNS zones, records, and monitor real-time traffic analytics for your zones. You can not only manage and discover your current DHCP scopes, but also define and manage new DHCP scopes, define your IP address plan, hierarchically organize your scopes, and manage all the DHCP configurations from one single window. In terms of DNS security, it implements advanced security features like DNSSEC, DNS firewall, response rate limiting, and DNS views, and more. For IP address inventory management, the IPAM module delivers precise visual snapshots of your IPv4 and IPv6 address spaces. It enables you to meticulously manage the allocation and usage of IP addresses, providing effective oversight to track the availability and usage thresholds in real time. So let's see the top DNS management features of DDI Central. Let's begin with DNS server and zone management. DDI Central offers complete control over your DNS server, zones, and resource records. It enables you to apply advanced DNS configurations like DNS64 using specific DNS options. Like DNS64 is a special service that enables an IPv6 only resource to access an IPv4 only resource, to access the resources of an IPv4 only resource using address translation. So basically DNS64 is an address translation service that will help in the coexistence of IPv4 and v6 addresses together. With dynamic DNS, you can securely apply dynamic IP updates to your DNS records. With DNS scavenging, you can maintain an up-to-date DNS infrastructure by automating the timely identification and removal of stale records. With DNS audit logs, you can easily analyze who's done what on each resource in your DNS infrastructure. With response rate limiting, you can regulate response throttling to mitigate the impact of DNS amplification attacks. With DNS query analytics, you can gain real-time insights into your network's DNS traffic. With DNS firewall and domain blocking, you can proactively block the access to malicious websites and redirect your end users to safety. With DNS ACLs, you can allow and deny certain hosts from accessing a particular domain. With DNSSEC zones, you can secure the integrity of DNS responses through cryptographic signature verification. So let's explore the top DHCP management features of DDI Central. Like DNS management, DDI Central also lets you to take complete control over your DHCP servers. It lets you manage your scopes, DHCP scopes, and you can define your IP address plan and you can manage them directly. For host IP mapping, you can easily view the host information associated with a particular IP that is being leased by the DHCP server. With host group mapping, you can group multiple hosts and manage them as a single entity and apply customized configurations for them. So this lets you to manage large-scale networks and enhance policy enforcement. The standard and custom DHCP options, you can specify extra configuration informations. These configuration informations are sent by the DHCP server to the DHCP client. DHCP fingerprinting is an interesting feature actually. It enables you to classify your clients and apply customized configurations to them. So for example, in your network, if you have certain VoIP devices in your network, and if you want the VoIP devices in your network to have a certain range of IP addresses, you can very well classify them according to their architecture type, and then you can assign IP addresses from a certain range, and you can keep them in a separate network. So the PIXI environment feature is a game changer here that supports the pre-boot execution environment for remote booting of devices, streamlining tasks like OS installations. Lastly, we have the DHCP failover capability. This ensures high availability of your DHCP service by allowing another DHCP server to take over in case the primary DHCP server fails, providing uninterrupted services to your clients. So let's explore the top IP address management features of DDI Central. We have the lease history, where you can see the evolution of an IP address over time. You can dive into the lease history to see who's been assigned a particular IP address for what period of time. This is very essential for change management, and you can easily view the IP address behind a particular you can view the host information behind a particular IP address, and then you can easily visualize both the stacks of IP addresses in your network infrastructure with dual stack IPv4 and IPv6 visualization. And you can assign fixed IP addresses to your hosts, and you can easily view the domain related information behind a certain IP, like it displays the DNS records associated with a particular IP, and also the DNS analytics for those DNS records, all from a single window. Let's see how you can solve all those critical network challenges effortlessly using Manage Engine DDI Central with a couple of use cases. Someone in my organization has accessed a malicious site. How do I prevent or remediate this using DDI Central? Previously, we saw how an end user with an infected device connecting to your office network caused potential problems and burdened the network admin with longer hours of troubleshooting. DDI Central, however, easily manages such situations with its DNS firewall. This firewall maintains a blacklist comprising a recognized collection of undesirable domains. Before the resolver can provide the actual IP address, it checks the domain against the blacklist. If there is a match on the blacklist, meaning the requested site is listed as a malicious site, the resolver does not proceed to fetch the real IP address from the external authoritative DNS server. Instead of connecting to the malicious site, the user is directed to a safety page. How it is shown in the image here. On the other side, the network admin can see the analytics behind these blocked domains. He can see which IP address has been accessing this blocked domains and the number of queries made to this blocked domain by a particular IP. So let's see how this is configured inside DDI Central. So to make configurations with the DNS firewall, you'll have to specify the malicious website's domain name, and you'll have to categorize it by specifying a specific category. And if you would like to block all the subdomains associated with that particular domain, you'll have to enable the block subdomains checkbox. And then more importantly, you should specify the redirection IP here. So that any end user in your network accessing this particular block domain will be redirected to this page. So you can add these malicious websites one by one, or you can bulk import them using a CSV file, and you can save these configurations. So once this is done, and when a particular end user accesses one of these block domains, you can easily go and view through the analytics page. You can see which IP address has made query to this particular block domain. So we can easily see here that this particular IP address has made queries to a block domain here, as mentioned here, and you can see the number of queries made by that particular IP. Immediately after this, you can dive into the lease history for that particular IP. And here you can see through the lease history for that particular period of time where the domain, when the domain block domain was accessed, and you can see the hosts associated with that particular IP around that particular time. You can also verify this using the DNS queries section here, and you can see the queries to that particular domain using the DNS analytics here. You get a holistic view of what's happened at what time with the lease history page. This brings us to another use case. How can I deploy various OS over hundreds and thousands of devices without any manual intervention? This is actually an example of how you can achieve zero-touch provisioning with DDI Central. It is quite common in many enterprises where network admins are given the responsibility to deploy customized OS configurations for different devices of new joiners, especially on a large scale. This is quite unimaginable if it's supposed to be done manually. Let's see how DDI Central simplifies this for you. DDI Central simplifies this with simple pre-boot execution environment configurations, or popularly known as PXE configurations, that will make the DHCP server do all the heavy lifting for you. The DHCP server here takes the responsibility of identifying each new device as a PXE client as soon as they are plugged into your network. Based on the device's architecture, the server instructs it to download specific operating system boot files from a TFTP server. It directs them to download specific OS boot files from the TFTP server. Let's see how this is configured in DDI Central. All you need is to create a client class and specify the instructions to be followed by the DHCP server for a specific architecture type using specific codes. In the conditional statement box here, you specify the architecture type and you specify the file name path that's supposed to be fetched by the PXE client from the TFTP server. Along with this, you'll have to make sure to specify the match value. The match value helps the DHCP server identify that the broadcast DHCP request is from a PXE client. Then you can apply specific predefined DHCP options, which are additional pieces of configuration information that are to be provided by a DHCP server to the DHCP clients during the lease negotiation. So here we specify the TFTP server's IP address via the standard DHCP option called next server. If you'd like, you can also customize this by defining your own set of options, and you can pass specific configuration informations to your PXE client. All this can be automated by your DHCP server for hundreds and thousands of devices as soon as they are plugged into your network without any manual intervention. This is a one-time configuration actually. You do not have to repeat it for every set of new devices joining your network. Configure it once with these instructions in place. Every time a new device is plugged into your network, the targeted configurations would be applied for that device. See how simple it becomes. In this session, I've discussed just 2 use cases due to time constraints. However, there are several potential use cases that can be effectively managed with a comprehensive DDI solution like DDI Central. With the evolving landscape of network management, it's clear that DDI technology sits at the very heart of this transformation. Whether it's the allure of the cloud, the necessity of security, or the innovation through automation and modernization, DDI is not a mere technical upgrade or a network utility tool. It is, in fact, a strategic enabler that underpins your entire network infrastructure, catalyzing performance and facilitating growth. With DDI as your foundation, the network becomes more than just a collection of nodes and connections. It becomes more dynamic, resilient, and poised to drive your organization forward. Let me wrap up the session now. Thank you for taking the time to be part of this webinar. Here's a support email ID. If you have any queries, please shoot us a mail at ddi-support@manageengine.com. This is your host, Akshara, signing off. Thank you.